So let's go ahead and get going then. Welcome everybody to the July 25th, 2024 meeting of the Technical Advisory Council of Confidential Computing Consortium. We get together bi-weekly because we think that working together as a community, we can make the world a more secure place with confidential computing than we could do as individuals or individual companies. Everybody is welcome to contribute to the meeting. In a few minutes, if you haven't had a chance to introduce yourself, we'll be asking people to introduce themselves, and sort of likewise, companies are welcome to join, and we'll be talking about a project proposal today. And so any project that meets our criteria for projects is also welcome to join. So I hope everybody is feeling welcome. We also abide by the Linux Foundation's antitrust policy. We have a bunch of different companies that might be competing, and so this one of the benefits of working together in open source is we've got this framework so that we keep everything in the clear. Today's agenda is going to change a bit. I got a last-minute cancellation from our Open Platform for Enterprise AI volunteer. They had an unfortunate emergency, so we'll get them rescheduled, but I might just give kind of a heads up on what they were going to talk about to introduce the concept. And then we have the data clean room proposal, and we might actually slip in what Catherine's been working on with the kernel SIG objectives before that to make sure that some of our later joining voting members can be present for the project proposal discussion. And then at the top of the hour, we've got another PQC talk, this from a noted cryptographer and friend of mine, Hart Montgomery. So he'll be joining at the top of the hour. Were there any other topics people were anticipating today? All right.
So sorry, the open platform thing, that's the TikTok project, is that right?
Nope. That is a AI project that's...
Oh, okay, sorry.
Yeah, no worries. Good question. But I'll introduce that in a few minutes. The TikTok proposal is the data clean room project.
Yeah, of course. Sorry. Thank you.
Yep. Anything else? Okay, I am going to skip over roll call, and we will come back to that after announcements so that we can make sure that we've got everybody. But if you have not introduced yourself to the community at least twice, you are more than welcome to pop off of mute and let us know where you're coming from and what your interest in confidential computing is and how you like to be addressed.
Hi, everybody. This is my second time, so this is it for me. I'm Jason Rogers. I'm the CEO of a very recent join thanks to the startup program. So I appreciate that. Excited to be here.
I'm so glad that you were able to take advantage of that. So it's great to have you here. And you're certainly not required to introduce yourself, but if you'd like to, it always makes conversations go a little bit smoother when people feel like they know each other a little bit. It also gives me a break to take a sip of coffee. Okay, let's go ahead and move on, but if you later want to introduce yourself, you can always jump in and do that. So just as a reminder, we went through last time, we've been making great progress with the OKRs, making sure that we all feel engaged in delivering something so that at the end of the year, we've got a list of accomplishments and everybody knows why they were spending time in the CCC. So last week, we heard from Henry and Kevin. from from Meta about what they'll be contributing this year and what they'll be leading. And one of the things that they talked about was maybe getting a project out of Meta into the CCC. So that would be super exciting if we get that. And then we had the second discussion on the data clean room project proposal. And so that should have wrapped up Q&A, and people had another 2 weeks to send anything by email that they were looking for clarity on. For announcements this week, I think we announced this before, but just as a reminder that there is this mini summit that's going to be alongside the open source summit in, somebody remind me where this is at. I think it's Austria.
It's in Vienna.
Yes.
Vienna.
Thank you.
Austria. Österreich.
Okay. So if you're keen to go to Vienna, we've got a good opportunity for that this year. I think that the Linux Plumbers Conference is also going to be there around the same time, so there's a lot of good things to hit. And that form that you see in the middle of the text there has a closing date of August 8th. So if you want to get some more content in, that would be great.
Yeah, I would add that last year we had some excellent sessions, really very good technically, and very, very interesting. So hopefully we'll have the same again. Please, it's a very good place to be seen. So let's do it.
Great. This is all I was aware of for announcements. I don't know if anybody else had news that we needed to bring out now. We did have a board meeting yesterday. I don't think there were any big surprises on there. The TAC budget, we are underspending right now. So maybe I'll mention that for those of you who are liaising with our projects, Gramming, Open Enclave, and so forth, we have budget available for test infrastructure that we're not hitting very hard. The travel budget, we're kind of hitting okay. But if there's ways that we can help accelerate the projects, that's what the money's there for. And I'd rather we spend it than bank it. Okay. So why don't we, Catherine, I know I asked you originally that we would go at the end of the session. Would it be okay if we slid you up abruptly to the front?
No problem. We can start with that.
Okay. Do you have a slide or anything that you'd like to share, or just talk through it?
No, I don't have a slide. If you could just point to the doc that we have been working on.
Great.
Everything is there. And I noticed some latest addition to the KRs from Meta. So if folks from Meta are around, maybe we can talk about that a little bit as well. And sorry, I missed the last most of last meeting, so I think I missed this part as well.
Okay.
So apologies for that.
It happens. I'm just navigating my way to the document. It is.
I just dropped it in chat for you, Dan. Oh, you got it. All right.
Thanks. Yeah, no, it just threw me off that the title is now, it has source of truth in the title, which is fine. My eyes glazed over it at first. All right, so just a reminder for people, or if you're new here, we've got 3 areas that we prioritize for the TAC. We want to be able to advance our projects. We want to be able to advance confidential computing in the ecosystem, and then we want to be able to grow a healthy community. And so what Catherine's been working on is related to our common dependence on the Linux kernel and being able to upstream features that are relevant to confidential computing. And so I will turn it back over to Catherine.
Thank you. So yeah, if you scroll down a little bit, you see the objective for the for this particular OKR is to getting a lot of the basic capabilities into the Linux kernel to be upstream. So then it's easy for cloud providers and other entities to adopt it for their particular usage. So we are very ambitious. We have quite a few that we're trying to push to the Linux kernel. The obvious one is the basic TDX enablement. It's very, I wouldn't say very, it's close to being upstreamed. So we need to get more, testing done, more reviews done, and ready it for kind of the final review and acceptance. So we are hopeful that by end of the year, we will be able to get that into merged into the main branch. We also have the GMEM 1 gig page support. There's still quite a bit of ambiguity and kind of uncertainty, the discussions there. So we would like to kind of align the community for the user API, get the patches posted for review, for comments. Not ready for review yet, but get the patches out there. There's a firmware hot load. So recently, we had a kind of few cases where we need to roll out firmware updates with a very limited time window. So this would be a very important feature for kind of real world usage of the CC. We don't want the unpatched sort of vulnerabilities linger around for a long time. So I think it's a critical feature for kind of real world adoption of the capability. So live migration for TDX is another one. We'd like to get it to be ready for review. So RTMR for TDX, guest patches, I think that have been around for a while also. So in the final stages of getting accepted in the main branch. And on the SMP side, we have the basic SBSN enablement, which will be very important for implementing the VTPM hardware rooted attestation, VTPM implemented for SMP, so that existing software ecosystem can make use of the attestation feature offered in the CC, compatible with the traditional VTPM based abstraction. And then the last one, maybe
could I just ask on that? Maybe totally fine if you don't have background on it, but with the Coconut project being in the CCC, which is great, I had viewed all of that work as within Coconut. Are there actually upstream kernel dependencies that they need?
I believe so.
Okay.
But my understanding is that there's still some kernel parts that need to be upstreamed. But if that's not the case, then we can revise this. But from my understanding, that there's still Yeah.
Yeah, and I don't know the space thoroughly. I know that Jörg sometimes joins us, the lead maintainer over there from Coconut SVSM. So I guess if anybody sees Jörg jump on the call later, we could always loop back into that. And sort
So
of
that-
similarly, I just
on that, like, so there are like a whole bunch of patches in EDK, QEMU, and kernel that Coconut SVSM says, oh, pull from these branches, and those Linux patches are the one that went upstream. So now you can take 6.12 branch and directly use the Coconut with the EDK2 and QEMU with SVSM.
okay, interesting. Thanks. Okay, sorry for the interruption, Catherine.
Yeah, so that's pretty much it from my side, but I saw a new addition on the from the I think from Meta on the open source library for establishing encrypted channels, tested channels with TEEs.
I can speak to Catherine, so maybe I can speak to this one. So I did plop this in there, kind of with a note that I send out saying, hey, if it doesn't fit, let me know. But I just wanted to explain why I put it here. So I put it here because how I interpreted the objective. And so the objective is worded, we facilitated collaboration for CCP projects, including with the Linux kernel. So the way that I interpreted this was that it's about facilitating collaboration, with the Linux kernel being one example of that. And then I kind of interpreted what the work that Meta was doing by open sourcing a project as facilitating collaboration. So I would say if this objective is specific to the Linux kernel only, then yeah, that KR does not make sense there probably. Unless it is related to the Linux kernel, but I didn't interpret it as it was. But if it's about broadly facilitating collaboration, with Linux kernel being one example of how that happens, then I think it could fit here, unless there's a better one, a better objective elsewhere in the doc.
Yeah, so last year we had, I think, a specific objective about growing the portfolio. And so any sort of new project recruitment fit nicely into that.
Yeah.
Maybe we should dust that off. In my mind, this particular objective is really about the Linux kernel, and I see the awkward wording with including now. So at the end of the day, I don't think it's a big deal where each one fits, so long as we're just all kind of working in the same direction on the same kinds of things.
I'll do this. I'll look at your past goals to see your past objectives to see what the wording was around the expanding the portfolio, pull that over and put this in there just to clean this up a little bit.
That'd be great.
Seem okay?
Thanks.
Perfect.
Yeah, and it looks like Kevin's on the call too, so if that makes sense for you, Kevin.
Yeah, it sounds fine.
Yeah, I mean, at the end of the day, you're working on seeing if you can get a project in, and probably doesn't matter exactly which bucket we put that objective in, or that.
Yeah. As you said, Dan, like as long as we're in the appropriate bucket, I don't really mind which particular objective we're under.
Great. Okay, and then not on the call, but also somebody who's been helping with the kernel SIG is Steve Rutherford. And we had talked about some just logistical things. Each one of the SIGs has its own style for recording meetings and managing agendas, but we like to keep everything as transparent and recorded as possible. And so I know recently he put up a link in Discord to where he's trying to now maintain agendas more consistently. And I don't think we ended up taking a key result for that sort of logistical thing, but that's just something else that's going on. Does that sound right, Catherine?
I'm sorry. Can you repeat the last
Yeah, I
one?
was just talking
Sorry.
about what Steve Rutherford was doing with trying to sort out the logistics. That at one point he was thinking about formally stating a KR for that, but I don't. I guess he didn't.
Yeah, I think we didn't take it further. I haven't heard about that development.
I think if it's useful to him to be able to kind of help recognize his contributions within your organization, then it's great to list it. If that's not necessary, then we don't need to have it tracked here.
Yeah, I think I'm fine either way as a KR or not. But if this is something that he wants to take on, we would certainly support doing that.
Yeah. Actually, maybe one thing that we could list is just the overall bootstrapping of the SIG, because it is new this year and getting everybody engaged is an important part of that. And we've already done a lot of that work, getting engaged out on LKML and bringing over the Discord from the secure device sub community there. So maybe, Ben, that's something we can add to the list. Maybe I'll just kind of live drop something in here. Something like that. And so all that stuff about having published agendas and recorded minutes and recordings, that all kind of fits within that, I think.
Sounds great.
Okay.
Thank you.
All right. Well, thanks for organizing all this, Catherine. It's great to have this all written out now.
No problem. I'll add more details of actionable items to it and evolve it continuously.
Excellent. Thanks. All right. Why don't we, I think we have quorum. So why don't we go ahead and switch over to the discussion about the data clean room proposal. Before the meeting, Fritz sent me an email that he's got a conflict, but should be coming in at some point when that's resolved. But he also expressed his support for the project should he not be able to join. So I just wanted to throw that out there. So typically how this works is after we've had a couple of conversations and everybody's had a chance to dig into the code and look at the project proposal, we should have vetted a short list of things. One is like, is it appropriately open source licensed? Is it using confidential computing or in some way advancing confidential computing? So it's within our charter. And based on a subjective assessment of the code, does it look like a good project for the CCC to host? And that's probably the most subjective thing on that list. The complete list of things that's in the proposal, we do need to verify all those things. So I've just kind of summarized things at a high level, but we've gone through that in the previous meetings. So after everybody's had a chance to go through it, which we're at now, the process is usually somebody makes a motion for a formal vote, and then we go through the formal voting process. So for TAC voting members, is there anybody who would like to make a motion to vote on this?
Dan, sorry, just a quick note. I absolutely think we should move towards a vote, but just in case you did ask people to have a final look, I just wonder if it's worth asking if anything has been brought up that people like clarified just before we move to a vote, just so that we've got that over with. Just for
that's an excellent point, Mike. If there's any last minute clarifying things that would be important for people to finalize their view of this, let's go ahead and open that up. I see Ming Shen is on. probably able to answer any questions that might show up.
And that's also partly because we generally like to do this by consensus. We generally hope that the vote reflects the general broad view of of the meeting and of everyone who's going to be here. So having a chance to bubble up any final questions seems like a good thing. So sorry, Dan.
That's an important cultural thing. No, I'm glad you bring it up, because we intentionally vote rarely, and we want those votes to just sort of codify the consensus that we've already reached informally.
I'm just gonna speak. So sorry, I missed the last meeting. So I actually at Google we kind of discussed this a bit, since the technology that part of the technologies that were deployed in this project was the confidential space product, and so we felt that this project is addressing a very important usage case, which is the data clean room and the data collaboration for sensitive data between multiple parties. So I do believe that this is within the charter of CCC, and technologies like this will help the adoption of CC confidential computing capability. So we also felt that the project is in a pretty early stage. So we have a few questions about the future directions. What are the so for now it supports the one-way collaboration. What is the timeline that we have for supporting multi-way collaboration, which is like the kind of the core capability of the technology? And also we felt that the documentation side is a little bit lacking, so it would be very helpful to improve that, so it's easy for customers, users to to navigate this and apply for their specific usage case. So other than that, we felt that this is a very solid project, and it's certainly within the charter of CC, and so we are supportive of this project. That's a kind of brief summary of our kind of position on this.
Great. Well, thanks for circulating that within among your colleagues within your company. It's something that I hope that everybody does with project proposals that come in. There's those of us that have the time and set aside the time to meet here, but we want the broader collaboration that happens offline. So that's great. Any other questions, comments? Would anybody like to make a motion to vote to accept the proposal?
So I'm new to this, so I assume that one person needs to kind of champion, in a sense, for the project.
Yeah, and you're a voting member, so you can do that, right? Google's a voting member.
Okay, so I would like to make a motion for a vote.
Okay, great. And I don't think we get overly formal about motions and seconds, but we do like to hear that assertive voice that people are ready to move with a vote. So with that, why don't we go ahead and do a roll call vote for those who are present. So Catherine?
Yes.
All right, I don't think we have Howard. Intel votes yes. Kevin?
I think Meta would be fine with it.
Okay. Thank you. Has Alec had? Yes, Alec is on.
I'll vote aye.
All right. Everybody's got a different way to say yes today. Love it. Fritz sent me that individual note. I think for maybe purposes of formality, I'll just ask him to send that to the list afterwards if he doesn't make an appearance, but I understand him to be voting yes. And then I think I saw Ram on.
Mike, I had not had the opportunity to go through this. Yeah, I don't know whether Yash is here. No, he's not.
Did you not see Yash? But it's totally fine to abstain from the vote if you're not informed on the issue.
Yeah, so I'll abstain.
Okay, so Red Hat / IBM abstains. And then I don't think there's any rule against TikTok not voting for their own proposal.
No, they mow it, and one assumes they will. I mean, I hope that you want to, Ming Shen.
Yeah, absolutely.
Good.
Okay, so with that, the vote carries, and we can applaud the data clean room proposal as the most recent TAC accepted proposal. And thanks, Vinny, for all the work that you did as well, getting us through this. So the process now, maybe Ben or Rian can speak to, but like the high level points are that it will have to go through legal review, which usually isn't a big deal. It's looking for things like trademark problems. And then it would go to a board vote. And what the board votes on is basically making sure that we followed all the steps and that the tax voted on it, legals reviewed it, and the other administrative things. Did I miss anything?
I would just note that the GB has never gone against the recommendation of the TAC as long as the legal stuff is all good. So the TAC is the determining piece of voting generally, but we have to wait for the legal just to be approved. I believe that there's already been discussion around that, Ben. Is that starting to happen already, the legal stuff?
No. So now that we have the TAC vote, so the next step here, and again,
Right.
we'll hold your hand through this process. So we'll reach out to you later today with an email with a form that you fill out that kicks off the process with our legal team. They produce a bunch of boilerplate documents that we'll go through with you, and yeah, once all that stuff is sorted, then we go to the board vote, which as we said here is usually just a cursory review, and then you're officially part of the CCC.
Thank you.
Fantastic. Well done.
Appreciate it.
Should be hopefully pretty painless. Yeah.
And I'm sorry it's taken a while, but it is important that we go through and everyone gets a chance to look at it. And three meetings is kind of pretty standard actually for this. We have had more. I don't think we've often had less. So good.
Yeah. Another great thing for your project as it finishes up going through that is getting a blog ready so that we can announce it and advertise it across all the socials too. So be looking forward to that.
Thank you, Dan.
All right, thank you. So I think we are ahead of schedule, but I do see Hart Montgomery is online. So why don't we go ahead and get into our post-quantum cryptography talk. So I am privileged to know Hart Montgomery from some work that we've done together with blockchain. Hart is a noted cryptographer and former student of Dan Bonnet, for those who are familiar with the cryptography circles. And he is currently the CTO of Hyperledger, which is a Linux Foundation project that promotes blockchain for primarily enterprise usages. And I think that itself might be going through a renaming process. But Hart, thanks for joining us today. And if you'd like to introduce yourself better, feel free to do that.
No, thank you, Dan. You are already too kind. All right, I'm going to try to share my screen. Can everyone see my screen?
Yes.
Wonderful. Awesome. And I want to keep this relatively informal today. So everyone, please feel free to ask questions if you like. If something is too complicated, let me know. If you think I'm insulting your intelligence, also please let me know. I'll try to watch the chat. Please let me know if you have questions. Dan, it looks like you have a question from Fritz.
Um,
Oh, I'm sorry, that was not meant to interrupt you. That was more like a social side.
Oh, yeah.
Go
Okay.
ahead.
So you literally just missed the TAC vote. I mentioned to people that you'd sent me a note offline in support of it. Do you just
Okay,
want
perfect.
to formally vote right now?
No, that's perfect. I just wanted to make sure I I wasn't sure that you got my email in time because it was a little bit late. But I'm happy. Happy that everything went fine. Then I didn't want to interrupt your talk here. Go ahead.
Sure. But since you're on right now, do you want to just say formally yes, you vote, and it's in the recording?
Yes, of course. I happily vote yes on the proposal.
Okay. All right. Thanks. All right. Sorry for the interruption. Take it away.
Totally fine. All right. Yeah. So I'm going to be talking about post-quantum cryptography. And again, please feel free to interrupt me if you have any questions or anything like that. This is a pretty small meeting. So I'm going to basically talk about three things today. I'm going to talk a little bit about the quantum cryptography threat and threat modeling that. I'm going to talk about the PQCA, and then I'm going to just briefly give you some details if you want to look at what we're doing. So let's get started. So the whole premise of this, and which I'm assuming you all are, generally familiar with, is that sufficiently large quantum computers can break essentially all traditional public key cryptography. And what I mean by traditional is sort of, all the standards that are in place today. Pretty much everything that people use today that's public key can be broken with quantum computers. I'm not going to go into the details. I can if you want, but probably not something we should really dive into today. So why quantum? And I will say that this was not my slide originally. This was actually an engineer slide, but anytime you can sneak in quantum complexity to an engineering talk, you have to have fun. But sort of they're easy problems, right? If you're familiar with complexity class P or BPP, things you can do efficiently in polynomial time. And then there are hard classical problems, which is, complexity class NP. And the thing is, what we think is that sort of the easy quantum problems are much larger than the easy classical problems. And unfortunately, a lot of modern cryptography lies in this intersection of easy quantum problems and potentially hard classical problems. So I'm not going to go into quantum computation too much, but the power of quantum computing is that you can compute things in what's called superposition. And this goes back to the Heisenberg uncertainty principle and physics. But, bits can be in a superposition of multiple values. They can be entangled. And, well, it gets very complicated. But there are a lot of neat things you can do with quantum computing. And I would definitely encourage you to take a deep dive if you're interested. So one of the most common, I should say, separations between quantum and classical computing is factoring. Are people here familiar with Shor's algorithm and factoring?
Can I say sure? Sorry.
Yes.
Sorry.
Acceptable, Mike. We'll take the puns when we can get them. So Shor's algorithm allows us an exponential speed up for factoring in discrete log problems. So the best factoring algorithm, is approximately, 2 to the d to the 1/3, where d is the number of digits or bits. Whereas Shor's algorithm is a constant times d cubed. And these are sort of hard to, think about because big numbers are typically very hard to think about. But I'll give you an example. So does anybody know about how many atoms there are in the universe?
3.
Great guess, Dan. No, so there are about 2 to the 300 atoms in the universe. So if you set d to be 1,000, using a classical algorithm, if you had every atom in the universe as a computer, it would still take eons, basically. Whereas, d to the cubed, is a billion, right? And that's a level of computation we can do today. Great guess, Benjamin. You win the Price is Right over Dan. I'll even give you credit for 4 factorial, which is even closer. So, just thinking about these sort of exponential speedups and exponential numbers are illustrative for thinking why this is so destructive to cryptography. Basically, you can't have a crypto system secure against anyone if there's a polynomial attack algorithm for it. So as I said before, essentially all of modern cryptography that's used today is at risk. So, if you use ECDSA or DSA, all essentially elliptic curve algorithms are broken. So this is a problem, right? Someone with a powerful quantum computer can just break everything. There's nothing you can do. You can't raise key sizes large enough to stop this. And that's sort of the fundamental point I want to make here. I don't think I need to tell you that the world depends on cryptography. It's getting more and more important. And, some things are quite frankly scary, like, to me at least, things like self-driving cars with over-the-air updates, where if a hacker could take that over, it would absolutely be catastrophic. But I don't think I need to convince you of this. So there are a lot of potential attack vectors that someone with a quantum computer could do. Obviously fraudulent authentication, forged digital signatures, but really the more problematic thing is breaking encryption. And this really gets into what's called the harvest now, decrypt later problem. Have people heard of this before? Some people, I see a couple nods. Excuse me. If you're not familiar with this, what this basically means is people today are recording your data as you send it across the internet, right? The US government has an entire nuclear power plant that is ostensibly hosting a data center, just to give you an idea of the magnitude of this. And they're not the only ones doing this. The problem is, if people are recording your data now and all your encrypted traffic that's going across the internet, suppose there's a quantum computer that comes along in 5 years. Well, if you need your data to be secure for longer than 5 years, you have a real problem with that, right? And so that's why sort of quantum security has been somewhat of a guessing game, as we'll go into later, because you need to adopt quantum computers, long enough in time that your data still going across the internet will, you need to move to quantum before that sort of time expiry happens and people can build powerful quantum computers. So this is a fun chart I like to show. So I'm a computer scientist, not a physicist. Don't ask me when I think a quantum computer will be ready, because that is a question for physicists. But this is a chart where, you know, they polled a bunch of quantum physics and quantum computer building experts, and they asked when a powerful quantum computer would be built. Or they asked these experts when they thought. You know, and you can see sort of the distribution, right, of percent likelihood and time. So there's not a huge consensus, but, you know, generally speaking, lots of folks are pretty scared about the 15-year time frame. Virtually everyone is scared about the 30-year time frame. And this is a real problem in some fields like finance, where in some cases you're required to hold on to data securely for 30 years. So, you know, this is one thing to think about. So how do we deal with this? Well, the answer is quantum safe cryptography. So there are cryptographic schemes which we think to be secure against quantum computers, as well as classical computers, obviously. But they rely on a completely different set of mathematical problems than traditional public key cryptography. There's a drawing of a lattice here, and lattice cryptography is one of the solutions proposed here, probably the most popular solution. I can answer all your questions on lattice cryptography if you like, but I'm not going to go into it today. So we need to switch to new protocols. You know, I will say there is an excellent course from IBM on this that they are planning on hopefully contributing to the PQCA. So hopefully we will have a lot of this content in the future. But check it out if you want to learn sort of more about all of these crypto systems. So how is this working? Well, there's been a huge standardization effort around post-quantum cryptography. It's been one of the biggest NIST efforts in a long time. You know, a huge amount of review by cryptographers. There have been a lot of schemes proposed, a lot of schemes broken. And we're supposed to have the first set of winners this month. I'm still waiting for the meeting where they announce them like the morning before, and I haven't heard it yet, but hasn't happened yet. We should have a first round of standards this month, and it will likely be these four protocols: Kyber, Dilithium, Falcon, and Sphinx. The first three are based on lattice cryptography, and Sphinx is a hashed-based signature algorithm, if you're familiar with those. So what are the issues with this? So I'm going to paint this with sort of a broad and general brush. Computation is not that much more expensive with post-quantum cryptography than traditional cryptography. These lattice-based schemes are, you know, actually quite efficient, and most people are using them. However, keys, ciphertexts, and signatures are much larger in size. And this is, you know, in some applications causing trouble, you know, because if you need, if you have an application where you have to process a lot of signatures or store a lot of signatures, then, you know, or maybe do a lot of repetitive key exchanges, this can be a problem. And usually the factor is something like an 8 to 10 factor. You know, for modern, you know, TLS use, maybe this isn't a problem. But if you're running a blockchain and you're storing a bunch of signatures on the blockchain, this could be very problematic if the thing you have to store most on your blockchain blows up by a factor of 8 to 10. So, you know, the hardware timeline, and I know you all are very interested in hardware, obviously, is really interesting to me because, you know, it's hard to put hardware into practice. I don't need to tell you all that. You all can probably tell, well, you all can definitely tell me more about that than I know. But to really roll out, hardware that uses post-quantum cryptography, we have to have finalized standards that everyone trusts because we can't really change them once we put them in hardware. The hardware has to be developed. The hardware has to be rolled out. And then, because of this harvest now, decrypt later threat, this all needs to be done, not only before quantum computers are out, or at least powerful ones, but also, in time that people can switch and still have their data be secure for the amount of time that they'd like. So, this all could take quite some time, and people may have long life expectancy for their data security. So
Hart, it might be worth mentioning that in the last meeting we talked about some of this stuff. Although obviously we do care about hardware, the general feeling is that most of the pieces that are involved with confidential computing is around the attestation, and most of that is actually in firmware or microcode. So we're hopeful that in our sphere of interest, most of this does not require hardware changes to be implementable, which is obviously a great win from our point of view. It doesn't everything, but that may help us, right?
That's fantastic, and yeah, I have a slide about cryptographic agility later, so that is wonderful to hear. Yeah, so Alec, it's not all network traffic, as Mike correctly points out. It's just the initial TLS handshake. So in a typical interaction with like a website, you use a public key to agree on a secret key. And then you use that secret key, use a public key to agree on a symmetric key crypto key, like an AES key, to handle the bulk of your communications. And so if you're interacting on the web and you're, talking to one website, say, for a long time, it means that, this extra traffic is not too much of a problem. For some applications, there are issues with packet sizes and other things, but in general, the communication is not a huge problem. If you are querying lots of different people and have, very short requests, that's when this becomes a problem. Sorry, Dan?
Just building on that question. So all of this applies to public key cryptography, but for the symmetric key cryptography, are there changes that need to go hand in hand with the new algorithms?
So this is a great question. So in theory, yes. In theory, there's an algorithm called Grover's algorithm that essentially allows you to do a brute force attack in the square root of the time, essentially, that it would normally take. So this is not an exponential speedup. This is a sub-exponential speedup. I'm sorry, it's the square root of the key. So it's half the key length, right? So, essentially, if Grover's algorithm had no overhead, then you could solve like, 256-bit AES, right, in time proportional to 128-bit AES, right? Because the square root is just a 1/2 in the exponent, right? That being said, we don't know the full efficiency of Grover's algorithm with like this is a polynomial speedup really, with quantum error correction. It might be expensive. So we don't really know how all of this works. For conservative choices, we typically recommend that you use like, AES 256 and SHA-512 for quantum security. But, doing so and switching to these longer keyed algorithms is considerably less disruptive than changing your public key infrastructure.
Thank you.
So did that answer your question?
It sure did.
Awesome. Great. So before I get into the PQCA, does anyone else have any more questions about, quantum or post-quantum cryptography that I could answer? Nope. All right, awesome. I'll keep going then. So to deal with this, we've had a number of companies. I think many people on this call are involved with some companies that are involved with this. But we've created a Linux Foundation umbrella project for post-quantum cryptography that we've called the Post-Quantum Cryptography Alliance. I think we are much less creative than naming with you all, and probably a lot less fun. The goal of this is to, advance the adoption of post-quantum cryptography by building high-quality code and really interacting with the research community and the developers as they continue to iterate on quantum and best practices. So we're overall structured in a standard LF project way, very similar to you all. So I don't want to go into that too much. We have a couple projects that I'll talk about. Right now we have the Open Quantum Safe project and the PQ Code Package project. Again, I said, less whimsical names than probably Dan and Mike would prefer, but it is what it is. And this is, kind of what the scope of the code base is today. So OQS is technically not marked as a ready for production project, but people do use it in production all the time today. We have a huge number of use cases on our website if you're interested. But the idea is to support development of algorithms and to implement and use new algorithms sort of as they move into the pipeline. NIST is not done. Even now, they're going to release an initial set of winners, but they're actively looking for, other schemes as well. So we expect to have a lot more, particularly development side of R&D in OQS. Then we also have what we're calling the PQ Code Package, which is mostly at this point high assurance implementations of the Kyber standard. And this project has a lot of people that are heavily involved with formal verification of cryptography. So there are a number of, there's a formal verification angle going on here as well, and there's some code around that. So let me see if I can answer the question in chat. So Alec asks, algos that have many individual connections during a workload will be heavily penalized. Algos that get a session key and keep the session key alive for the entire duration will not see much impact. Yes, that's exactly right, Alec. Completely correct.
Well, yeah, when you say
let me just say, I didn't want to sidetrack the presentation here. Maybe we can have discussion after the presentation.
Yeah, because things like session reestablishment is different to rekeying, which may be a lot cheaper.
Sure.
Right? So
that's true.
Yeah.
If you store the, if you store the session information, that's great. There are some there's some protocols where you generally want to generate a fresh key every time, and there are advantages to doing this. But that's probably out of scope. But Mike, you're exactly right that if you're caching, session keys or whatever, then you don't suffer from this. But if you're interacting with new people, or people where you haven't done, a public key interaction with before, then it's definitely problematic. Happy to have questions. Like, don't feel shy about asking. So, awesome. Okay. So as I said, we really want PQCA to have, an experimentation angle as well, because a lot of these new standards are coming out. They're still coming out. We want to be able to test them and prototype them and give feedback to the researchers that are developing them about what works and what doesn't work. So, somewhat unique to LF projects, we do have a full research track where we've got code that, we're clearly saying, don't use this in production. This is just for us to be able to test out new standards. So a few more details, a little bit about each of the projects. So the OQS project, all of your favorite standards at this point. There's also an SSL provider, if you're interested in that. That gets a lot of attention and people really like that. And we have also added some really nice demos if you want to see that. So check those out if you're interested. Just a short list of who's involved. We have a lot of folks, a lot of big companies, mostly tech companies at this point. And we'd really like to get, less traditional tech companies involved. Things like finance, more system integrators. But we're very open and happy to have contributions. So if this is something that you'd like to get involved in, definitely let us know. Oops, sorry about that. As I said before, the PQ code package is heavily focused on formal verification. We've got a bunch of folks from IBM Zurich working on this, as well as a lot of folks from the European academic cryptography community. But the goal of this is to have formally verified, extremely hardened implementations. And that's it right now. We're expecting a bunch more projects. We're probably going to have a CBOM project coming in very soon, if that's something you're interested in. Are people here familiar with CBOMs? So this is a cryptographic bill of materials. You've probably heard of SBOMs. So this is a sort of cryptographic equivalent of that. Just, what cryptography are you using? What implementations? Essentially serve the same purpose as an SBOM, but for cryptography. And so, looking forward a little bit, the goal is to have a complete PQC stack. We want cryptographic agility providers or APIs, libraries, base level implementations, formal verification, CBOMs. We understand that, we need to make it easy to use and switch to PQC, or people just won't do it, or they won't do it well. And this requires, a lot of tooling and a lot of ease of use software, as well as the core protocols. So that's our goal. And I think this goes back to Mike's point on cryptographic agility. So yeah, I've got a little bit of project information here. If you want to check it out and see what we're doing. We're an LF project. We're completely open, obviously. So, feel free to check it out and join. And that's about it. That was about right on 25 minutes, I think, Dan. So
expertly done.
Happy to answer questions if anybody has them. And I can post my contact information in the chat, or you can find me. And I'm always happy to answer questions later as well. Any
so
questions?
this is really great. Thank you, Hart. I think you've dealt with quite a lot of the questions we already had. I think the interesting stuff is, around where, as you said, we recommend attestation where we care about this, because that's where the asymmetric crypto generally happens in confidential computing. And I think there are going to be questions like how. One of the things you need to do with attestation, of course, is verification as well. So is there impact for verification times for attestation measurements that we're going to need to think about for attestation services. Is that a fair question? And whether hardware will come along that'll help if that's the case.
Yeah. So yeah, people are optimizing hardware for this stuff. Definitely, that's already happening. And as I said before, the verification time for attestations won't go dramatically up unless you're doing fancy cryptography for your attestations. If you're doing like zero knowledge proofs or trying to do post quantum snarks, those are much more expensive than classical. But this is really in the research domain, and you're probably not doing that. For basic signatures or other simple attestations, it's not really the time that goes up. The time is very fast. Like verifying a lattice-based signature is super fast. The problem is the key sizes again. Just having to store keys and deal with key management is the real issue.
Yeah, I mean there has been some discussion of things like Z or ZPKs as part of attestation measurements. I think there's some really interesting verification. So there's some interesting questions around there, and I think it's something that we need to keep an eye on. So that's really helpful. I'll step aside and let other people ask questions. Thank you. I'll
comment before going to the next question that I think ZKPs are the wave of the future. Because we're going to want, as more and more stuff becomes online and digital, we're going to want more and more privacy. And so I think in the future, you're not going to present a credential. You're going to present a ZKP that you have a credential. The EU is strongly considering this already for their digital ID solutions. So I think it's just a matter of time. And sorry for the sidetrack. I think Fritz is next.
Yeah, I mean I want to ping in on the same thing that Mike said, and so there's a slightly different angle also to the performance thing, right? So it's not. I don't think it's correct to say it's gonna be fine with scaling completely, because if you look at kind of attestation, if you want to do it fully post quantum, basically the crypto processors have to support sending a PQC attestation at a high data rate, right? And so depending, of course, on the device, if you just have to send one attestation, sure, it's maybe going to be a little bit more. But if you have a device where you expect to send thousands or tens of thousands, I don't know where we want to go in 10, 20 years, right? Of attestations every second, then suddenly every single bit of percent that you increase in performance will break your neck at every single step. And so I think it's going to be interesting to keep in touch between yours and our groups, because even if for most of parts maybe performance might be done or might be feasible for lots of these software projects, there is still going to be a lot of hardware rooted elements that we need to support here, right? So and I think all of these requirements that CC maybe adds on top might also make it more difficult. So yeah, I would like to see more or us kind of meeting at least every half year or so to just kind of stay in touch and see what new use cases we have and as it may arise or something. Maybe we can come up with some process there to keep talking.
Yeah, absolutely. That would be fantastic. I think Mike.
Yeah, so I'm kind of wondering, are there any shortcuts where if you're doing if you're doing signatures, which is what we're talking about quite a lot here, and you're obviously sending a certificate, I guess that you may not need to send the entire key in each occasion, right? If you're having multiple communications.
Mm-hmm. That's right. Yeah.
So you may be able to shortcut at least some of the transport costs there, right?
Yeah. I mean, the thing is, it's not just the keys that are larger; it's also the signatures themselves.
Yeah. Okay.
So you get hit a little bit there as well.
Right. And they the same sort of factor in terms of size, larger?
A little bit less, but you can't do things like in a BLS signature, for instance, right? You can have a signature that's a single group element, which is very compact.
I'd love to see if there's been some easily. I mean, I'm not a cryptographer or a mathematician, to be entirely clear. I'd love to see if there's some easily accessible and digestible work on what these sizes look like and what work's being done in terms of optimizing, whether it's for transport costs or computational costs and stuff as well, if that's happening within this world.
Yeah, and this is a big thing. There are a lot of people looking at this, like particularly the signature size issue. So there's a whole new mathematical or a whole new set of signature schemes based on a mathematical assumption called elliptic curve isogenies. And these are essentially mathematical maps between elliptic curves. And inverting these maps is conjectured to be hard for quantum computers to do. So these schemes have the advantage that they do have signature sizes that are like almost relatively comparable to traditional group-based cryptography. However, the sign and verification times are expensive.
I love it when mathematicians use words like conjectured. He's like, we think it's probably the case, but no one's actually proved it yet, so who knows? But that's a good start, right?
Well, I mean, we can't prove that, we can't separate.
I know.
So, we can't prove anything. Absolutely.
I'm being mean. This is all good stuff. It's great. Thank you. Sorry, I'll shut up for a bit. I think Dan and someone else got the hands up.
Yeah, no, I'll just follow your lead a little bit on the signatures. Maybe the slide that you had that had the finalists from the competition. I think the first couple were meant for key exchange, and then the last couple were meant for signatures. But it might just kind of help people connect the dots on which algorithms we're talking about. And I think Falcon stayed on the list because it was more compact.
That's right. Falcon is a little bit more. Falcon is the most compact lattice-based signature scheme. Yeah, I can try to page back to that slide. This one, right?
Yeah.
Yeah. So dilithium, Falcon, and Sphinx are all signatures. Kyber is a chem. Dilithium is slightly so Sphinx is a hash-based signature scheme. This means it only uses the security of essentially hash functions, so probably SHA, which we widely conjectured to be secure. However, this is a stateful signature scheme, which means it's annoying to implement, and the computation time and the parameters are generally very large. So this is if you want to be extremely conservative and you don't trust lattices. So dilithium and Falcon are two signature schemes based on lattices. There are sort of two fundamental kinds of signature schemes. There's a Lubashevsky and there's a GPV. Dilithium is the Lubashevsky. Falcon is what's called a GPV signature. They're sort of different in how they're done. Dilithium has a little bit larger signatures, but Falcon is sort of a nightmare to implement in a way that's secure against side channels and other attacks.
So a couple of thoughts. Firstly, do we think that when we say side channels may well be different if you're implementing within a trusted execution environment, and it'd be very interesting to see whether people have thought about that and done any work on what the side channel attacks look like there.
They have. So unfortunately, like using a TE does not help you against like a timing attack very much.
Okay, so a constant time is difficult for this, is it? This sort of
Yeah.
stuff.
So Falcon is very dependent on sampling noise in the shape of what's called a discrete Gaussian. This is like very problematic and difficult to do in a way that is both efficient and you know, and resist timing attacks. So like the classic way to sample a discrete Gaussian is to do rejection sampling. And that's not, it's highly timing variable. It's just difficult to get right. So.
Okay, so I had another question. That was kind of a follow-on from that one. If other people have questions, please go first, because this is I don't want to be taking all this stuff up. I hope this is useful for other people as well. So my question
I just had one thought on the signature stuff, because Mike, you had asked about different tricks to make that smaller. I think ECDSA has a property that you don't have to send the public key if you're sending the message, if I'm remembering right, because you can extract that from it. Does Falcon or Dilithium have a similar property?
No, that is group magic that is specific to ECDSA. And if you want maximally small signatures, you should use BLS signatures. They're sort of as small as possible.
Okay. Thank you.
Okay, so if I may go back to mine, if that's okay, Dan, unless there's anyone else. Yeah. Mine was about encumbrance. So I'm assuming that all these are open source, and that because everything NIST is open, is at least IP unencumbered. And I do know there were, in the early days of ECC, for instance, there's a lot of issues with IP encumbrance. How's the field looking generally in terms of patents and all those sorts of nice things?
So NIST generally only picks things that they don't think will be IP encumbered. So this is all essentially clear to go.
Okay. And what about the rest of the field? Is there stuff happening out there, people are being nice about, or, how are these, how's it looking, would you say, in the field generally?
In what sense?
Well, I'm sure there's other people, doing startups and things around, quantum resistant or post-quantum. Are we worried that they're going to, significant speed ups or hardware implementations of speed ups that will be IP encumbered, for instance? Because that's a classic area where you've got hardware improvements and performance improvements, and they can be IP encumbered.
Maybe, but most of the work on this has been done in the open by academics. I mean, I would say there's been a real shift over the past, probably 20 years, where basically cryptographers figured out that if you patented your cryptography, no one was going to use it. Yeah. Even if it was better than what existed, right? This is the iconic case is Schnorr signatures versus ECDSA signatures, right? Schnorr signatures are just better than ECDSA signatures, but no one used them due to patent restrictions. So, certainly I don't know of any optimizations that have IP protections that are, public. It's possible someone has done things, that are not public, particularly if they're specific to a certain kind of hardware.
That's really, really helpful. I mean, I happen to be involved in the ECC world about 20 years ago, so I was very aware of the of what's going on. That's really helpful. Thanks, Hart. Really like that. Thank you.
Yeah, the big shift away from patent protection. So
cool. Thank you.
Anybody
I'll
else?
just ask one clarifying thing, because you said a minute ago that for minimal signatures we should use BLS, but that's in the context of classical, right? There's not a PQC construct that.
Not
Yeah.
PQC.
Okay.
Yep.
Right. Thanks for that.
Yes. There are, well, sorry. BLS has a lot of nice properties as well. It's essentially trivially thresholdizable. And that's something that we can't really do nearly as efficiently with post-quantum signatures yet. So.
Is it just me who thinks JLS whenever you say BLS? I think K-pop, and it's just not helping my head. It's just me,
No,
right? Okay, that's
just
fine. Okay.
Or at least it's not me.
Yeah.
No, that's I'm very pleased for you. You don't need it, please.
All right. Well, thanks so much, Hart, for giving us so much of your time today. This is fantastic talk.
Much appreciated.
We do
Let's
put
keep
all
in
of
touch.
our and we do put all of our video recordings online on YouTube. And if it's assuming it's cool with you, we will also usually cut out the tech talks and post those separately.
Sure, whatever you like.
Wonderful. Thanks again.
As long as Mike doesn't dub me into a K-pop video.
Now you've given me ideas, you see. The fact that I have a favorite K-pop video says more than it. Yeah, I'll stop. Thanks, Hart.
Thank you all very much for your time. And
hey, Mike, no more trips to Korea for you. I think we're going to ban you.
I think that's probably best. Yeah, no, that's fair enough.
Anyone here, please feel free to reach out and get in touch if you have questions or if there's something I can help you with.
Thanks again, Hart. This is great.
Fantastic talk. Thank you, Hart.
Yeah, really good.
And Ben, I don't remember if we took a PQC goal for the year. I know that was one of the things that the board asked us to look in, and that's kind of what precipitated putting together some of these talks. So maybe we can follow up offline to make sure that we're recognizing that.
Yeah, I think it's worth saying, Dan, this is one of those areas. There's been a couple over the last couple of months. One is Web3, and the other is PQC, where we've had, I've been seeing in the industry and in the ecosystem a growing amount of interest. People just asking me about it. So I think it's really important that we're covering them in the TAC, and this is one of the great benefits of how we work in the TAC, that we have these sorts of really quite complex discussions with real leaders in the field. So it's really very positive and great for the community. So thanks for making it all happen.
Absolutely. Okay, so we're about at the end of our planned agenda. As I mentioned, our other guest speaker for today, who's going to talk about this AI project, had an unfortunate emergency. So we'll look to reschedule him. But to still kind of get people to maybe get some exposure to this so that we can have a more interactive discussion, I'll point people to this project. In addition to PQC and some of the other things we've talked about with secure supply chain, the board's interested in making sure that we're thinking about presenting how confidential computing assists AI. And so for this project, paste the link into chat here. This is one of, I'm sure, many open source projects for artificial intelligence. One of the benefits of this one is it is also under the Linux Foundation, as you see at the top, and there's a number of companies that are supporting it. We scroll down to the logo sheet. My engagement with this project is I've been asked to help lead up their security working group so that they can build with a security first mindset. And part of my preconditions for that is that I get to talk to them whenever I want about using confidential computing. So I'm going to be looking to influence them to incorporate things like attestation into their various use cases that are supported here. I'm always looking for crossover opportunities, kind of like how Hart just presented the PQCA project. We'll maybe want to do something similar with OPIA or other AI projects. So maybe thinking ahead to when we have that speaker come in, if you've got 5 minutes and you want to dig around to see what's going on with this project, there's a couple easy architecture diagrams. Maybe that's not easy to look at. But I can give you a quick tour so you know where to poke around. If we go to their GitHub link to have kind of like the software view of the project, there's two main repos. Well, I guess, Docs is always a good repo to take a look at if you're not familiar with the project, but the two main ones are the examples and the components. So GenAI Comps is the set of microservices that can be composed to deliver different use cases. And then the examples show some of those compositions. And I think those are probably good starting points to jump in. Each one of these things can be built as Docker containers. And I'm still fairly new to the project, but I was able to build things with no problem with the instructions that are there. But yet another good way to interact with a project for the first time is if you do have problems with the instructions that are there, filing an issue is something that's really helpful, especially in these younger projects that haven't had a lot of people try things on different kinds of hardware, different kinds of setups, and that might not work with the unintended assumptions that are there. So that's the little teaser for the AI project, and I can answer any quick questions on that. Otherwise, we'll pick that up at a future time. One other thing that occurred to me as I was looking at attendance this morning, which was a little smaller than normal. I know we are in summer vacation season for those of us in the Northern Hemisphere. And I wonder if we could do a little poll somehow so that we know if we're going to have good attendance in the August meetings. So we could maybe send out some sort of poll to the mail list, and that's probably the good way to get people who aren't here. But especially for the voting members, in case we have any voting issues to come up, does anybody know for sure that they won't be at the August 8th meeting? Okay, so sounds like we should probably have good attendance at the August 8th meeting. I think I have a non-vacation related conflict that might be during that, so I might need somebody to fill in to chair the August 8th meeting. Would anybody like to volunteer now? And I can confirm with you later if I am indeed unable to make it.
I'm willing to. If nobody else wants to do it, I'll be here on the 8th.
Thanks so much, Alec. So we should be able to get an agenda together for you so that you don't have to deal with that part of it.
Yep, my vacation was in June, so I'll be here.
Great. All right. Well, I guess last call for any announcements, issues, other remarks. All right. Well, everybody gets nearly a half an hour back today, so look forward to continuing to work together over the next couple of weeks. And for those of us who will be at the meeting on the 8th, everybody gets to see each other then.
Thanks very much, everyone. Bye.
Thanks, folks.
Tim.
Bye-bye.
Bye.